All right, so here we have 4.2b, which is solving matrix equations. Equations. And the objective to this is to solve matrix equations and multiply a matrix by a scalar. So we'll talk about what that is here in just a moment. We're actually going to start by multiplying a matrix by a scalar, and then we will utilize those skills to solve a matrix equation. Again, matrices are almost kind of like a breath of fresh air because they are a lot simpler. And so let's go ahead and look at this first set of directions, which truly is to multiply each matrix by a scalar. So for number 1, I have -3 times the matrix of 7, 8, 0, -2, -4, 12, 9, -5, and 3. And so truly, when you multiply this matrix by a scalar, you distribute that -3 to every single piece inside that matrix. I view it as, like a waitress or a waiter bringing you all your food or drinks or something when you're sitting at a restaurant table. Every single person, even if you have a big party, gets whatever they ordered. So I end up with getting a -21. I didn't quite make enough room. Oh dear. I didn't make enough room with this matrix. I need to refix this line here. So I get -21, -24, 0 for my first row when I multiply -3 times 7, 8, and 0 respectively. And then I end up getting 6, 12, and -36, again with multiplying that second row by -3 respectively. And then -27, 15, and -9. And at this point, I have multiplied a matrix by a scalar. So that's really all you need to know with multiplying by a scalar. Now let's just jump straight into solving an equation. Okay, so the directions here are solve each equation. So number 1, I have -8, I have a 4 by 1, I have -8, 20, and I did not make this matrix long enough, 15, and -2. Okay, and that equals -2x plus -3, 7, 9, and -1 in that 4 by 1 matrix. So for something like this, truly, when you're solving an equation, you are wanting to get x by itself. So the first step in doing that is to go ahead and subtract this matrix here on both sides. So the -3, 7, 9, and 1. So I need to subtract -3, 7, 9, and 1. And when I do that, just like when we were adding and subtracting the other day, when you go to subtract, you do need to add the opposite. I highly recommend doing that so it doesn't throw you off too badly. I am going to have to go on to the next page in order for us to see this. So when I do -8 plus 3, I do get a -5. When I do 20 plus -7, I do get a 13. When I have 15 plus -9, I get a 6. And when I have -2 plus -1, -2 plus 1 is a -1. Okay, so that was from adding these two matrices together. And that equals -2x. So just like multiplying a matrix by a scalar, when I need to go solve an equation, I need to actually divide. I'm basically dividing by a scalar, if that kind of makes sense, because I need that x alone, so I need to divide by -2. That means each and every component is divided by the -2 in the matrix. So we're going to end up with a lot of fractions, and that's okay. So my final answer, negative 5 divided by negative 2 is 5 halves. And again, I never make these matrices long enough. Lord have mercy. I may as well just wait until I have all of it written. Then I have 13 divided by negative 2 is negative 13 halves. Or, I mean, technically you could say negative 6.5. That's fine. Or negative 6.5. I have 6 divided by negative 2, and that's going to be a negative 3. And then I have negative 1 divided by negative 2, which is a 1/2. So therefore, that is what x equals. So if I would substitute x back in and multiply it by this scalar of negative 2 and add it to that matrix right here of the negative 3, 7, 9, and 1, I should end up getting that negative 8, 20, 15, and negative 2. You don't necessarily have to check your answers, but that's how you would truly check those answers. I have 2 more problems to look at with you. I'm going to go ahead and save those for the next video because they shouldn't take me too long. Again, matrices are a little bit simpler. There really aren't a lot of notes to take on it, but just to kind of break things up, I've got 2 more problems for the next video.